Okay, this is a quick overview of Lesson 18, to use parallelogram properties. For this lesson, we have the properties going back from what we had on Lesson 17 about parallelograms, and this is what you have to know. So, Lesson 18.1 talks about parallelograms, that their opposite sides are congruent and parallel, so that's the first lesson. The next lesson, just to quickly go over it, are going to be talking about how the opposite angles are congruent and that the consecutive angles are supplementary. And then 18.3 is going to be talking about how the diagonals of a parallelogram bisect each other. All three of those things, if any of those are true, it proves that it's a parallelogram. So you could actually make this into a conditional statement like this. If a quadrilateral is a parallelogram, then the opposite sides are congruent and parallel. You could also say the converse of that. If a quadrilateral has opposite sides that are congruent or parallel, then it is a parallelogram. In fact, that reminds me, what I should do is I'm going to change this and to meaning or, because that's technically what this lesson is about those. They can either be, the opposite sides can be congruent or parallel, and then that proves that they're a parallelogram. So here we go. So this first case, this is what it talks about, is there are these four cases, which I would not memorize the cases, I would memorize the idea behind them. So case one says that this line is parallel with this one, and this one is parallel with that one. So that's case one. If that's true, it's a parallelogram. The next case says if KN is parallel to LM, and if KL is, not parallel, congruent. So if this side is congruent to that side and this side is congruent to that side, it's a parallelogram. So notice that this case one talked about parallel, case two talked about congruent, case three and case four are combinations of those. So case three says if KN is parallel to this one, and they're also congruent, so I'm going to put this mark on there, then that means it's a parallelogram. Lastly, if KL is parallel to MN and KL is also congruent to MN, then it's a parallelogram. So that's what the first lesson is talking about. And here is a proof of it. So we are given that PR is parallel to TS, and we know that R is congruent to T. So notice that they have this dotted line in here, that it's called an auxiliary figure to help us do that. So we start out every proof with given. And then we're going to look here. RPS, so RPS, so that's talking about this angle, and TSP, that angle, are alternate interior angles. That's just by definition of what they are. Now this one says that they're congruent, saying that that's what it says. Then we have PS is congruent to PS. So let's see. We had one arc here with a line. I guess we could say this is two arcs and two arcs. And then it tells us that PS, because you can see both triangles, so the upper triangle and the lower triangle both share PS. And we know that that's the same by the reflexive property. So we have an angle, and a side on both of them. So this reason 5 would be angle, side congruence. So now we know that these two triangles, so this lower triangle is congruent to the upper triangle. And again, make sure that side. And how I know that is by angle, side. But now that we know that, now we can say that PRST is a parallelogram because of a long explanation, which is basically if you have one, so now we know that we were already given that these two sides were parallel, PR and TS. But now, because now we're stating that they're congruent, so this side is congruent to that side, it goes back to this reason right here, like if they are congruent and parallel, or parallel, I should put both of them, and or parallel, then it is a parallelogram. So that's a big long reason. This is my summary. If one pair of op sides is parallel, so that's my symbol for parallel, and congruent, so parallel and congruent, then it is a parallelogram. Okay, so that's 18.1. 18.2 talks about the opposite angles, and so that the opposite angles are congruent, and that the consecutive angles, the ones right next to each other, we also call those adjacent angles, are supplementary. They add up to 180. So here's the cases for that. So you could say, and here's what it is. If A is supplementary to B, meaning that they add to 180, and it's supplementary to D, then it's a quadrilateral. Then it's a parallelogram. So same thing going with B and C and D. So basically, if one angle is supplemental to both of the angles on either side of it, then it is a quadrilateral. The quadrilateral is a parallelogram. So we're looking for whether or not it's a parallelogram. So one angle supplemental to both things, supplementary to both of those things, and then boom, it's a parallelogram. The quadrilateral is a parallelogram. So this one is really small. Let me show you how to use this. It is right here. Okay, so this one is a little bit funky because it's giving us this proof, and then it's telling us at the end that there are two mistakes that were made in the explanation, and so we have to be careful with it. So we are supposed to prove that this is a quadrilateral. It tells us that AD is parallel to BC, and that angle A is congruent to angle C. So then they go here. So angle ADB, and I have to mark these. So I'm going to mark this with purple. ADB, that angle, is congruent to angle CBD. All right, and so they said it was because of alternate interior angles. That checks out. Then they said that they're congruent. Also checks out. Then they said that this side is congruent to itself by the reflexive property. That checks out. Now they were getting into some funky stuff. So, not quite yet. So they said that triangle ADB is congruent to triangle CBD, meaning they said that this triangle is congruent to this triangle, and the reason they said was angle side angle. So let's look at what we had. We had this angle, and then this side. And again, angle, side. So it's not by this. It should have been by angle, side. So that was the first mistake. Then we go into the other things. So ADB, oops. Angle ADB is congruent to CDB. So ABD is congruent to angle CDB. And that's now, because we have the triangles, that makes sense that its corresponding parts are congruent. Triangles are congruent. Then they're saying now that D is made up of ADB, so this one, plus CDB. So they said that's made up of that one. But then they used two tricky things on this next one. They said, because we have this statement, and right here we have ADB, we can replace this with that where ADB is. Then we used this statement down here for this part, and they said we could replace CDB in place of that one. So then we get this new statement right here, which is true. So first of all, angle addition postulate, that worked. We substituted twice on this one. And then at the same time, we also said that what angle B added up to, which is also true. So then we had, okay, so then now angle B is the same as D, substitution property, those are all true. And then this is really close. But the problem is we talked about, it says the both pairs of opposite sides. We didn't talk about sides, we talked about angles. And that was the other mistake. So down here, we would need to mark that reason 11 is incorrect, and that was reason 5 is incorrect. Angle side. Here's the next proof. It says that we are given that KL is parallel to LM, measure of angle K is that, measure of angle L is that. So we just did the given. And then K and N are, so K and N are, and then we look at our options here. What kind of angles are K and N? Well, they are same side interior. They're not corresponding, and they're not congruent. They're just same side interior angles. And then because of that, we can say that they're supplementary angles because of the same side interior angles. So that goes in both of those spots. Okay, then we have 18 point, which is the diagonals of a parallelogram bisect each other. So here's this crazy looking thing, and all these options are bazonko crazy. So we're going to go through and figure out what the deal is. This is the big hint. You can show that it's parallelogram by showing that its diagonals bisect each other. So now what you're doing is you're looking for things to show that the diagonals bisect each other, which would mean that you'd show that their triangles are congruent. So you have to make sure that the triangles match up. So let's go through each one. They're tiny, but they're okay. So angle 1 is angle 2, and then you'd say that 3 is 4. 3 is congruent to angle 4, and that would be by vertical angles. And then they're saying that NE is congruent to LE. And that would be a good example that you could do with the definition of a midpoint of LN. But then they're saying that triangle KEL, and you can't do triangle KEL because that's not what we just talked about. So not that one. Then go down, it says angle 1 and 2, angle 5 and 6, which we cannot say angle 5 and 6 because we don't know that L and M are parallel. So we can't say that one. Like, that's the part that I get stuck on. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Any LE triangle KEN, K-E-N, is congruent to triangle MEL by the side angle side congruence. So let's see, we have, looks to me like we have an angle, a side, and an angle. So it's not side angle side. So it's the same thing, but we want angle side angle. So it's the last one. And the last one for all of lesson 18 says that we need to prove that this is a quadrilateral. This quadrilateral has a parallelogram. So we start out with given. Then it says that NE is congruent to LE, and KEN, angle KEN and MEL are vertical angles. Vertical angles, definition of vertical. And then KEN and MEL are congruent by the vertical angles theorem. And that's all you have to know for that one, apparently, because we've already done that part. So that is a quick overview and the examples in chapter 18 and lesson 18. So from there, you can get the homework done.